Equivalent ratios have the same value. For example, the ratio 1 to 4 is equivalent to the ratio 2 to 8. 3 to 2 is equivalent to 27 to 18. And 5 to 7 is equivalent to 35 over 49. No matter how the ratios are written, they all have the same value. To see why, let's look at an example using a tape diagram. So Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. So here we can see that in the tape diagram below. What does each unit on the tape diagram represent? Well, that's the question. They're not marked, and there's lots of different units we can assign to them. So first, let's assume that each unit represents 1 inch. So as you can see here, each unit has been filled in with 1 inch. What are the lengths of the ribbons? Well, Shani's, let's count, is 1, 2, 3, 4, 5, 6, 7 inches, and Mel's is 3 inches, 1, 2, 3. So the ratio of the lengths of the ribbons is 7 to 3 inches. But now let's assume each unit represents 2 inches. What are the lengths of the ribbons now? Well, now we have 2, 4, 6, 8, 10, 12, 14 inches for Shani's ribbon, and we have 2, 4, 6 inches for Mel's. So the ratio of the lengths of the ribbons is now 14 to 6 inches. But again, it can be any unit we choose, so let's finally pick another unit. Let's assume each unit represents 5 meters. What are the lengths of the ribbons now? So Shani's, we can see, is 5, 10, 15, 20, 25, 30, 35 meters, where Mel's is 5, 10, 15 meters. So now the ratio of the lengths of the ribbons is 35 to 15. If we look at all three together, though, when simplified, we will see that the ratio remains the same. First, when it was 1 inch units, we had 7 inches to 3 inches, or 7 to 3. Then when it was 2 inch units, we had 14 to 6, but that has the numerator and denominator can both divide by 2, so that's still 7 to 3. And then when each unit was 5 meters, it was 35 to 15, which again, if you divide by the 5 meter units, is 7 to 3. So all ratios were equivalent. When two fractions are equal to each other, then the ratios they represent are equivalent as well. So even if we wrote them as the fraction of 14 over 6 and 7 over 3, even if we wrote it with a colon, no matter how you write the ratio, they're going to be equivalent. Now, there are 2 ways to determine if ratios are equivalent without tape diagrams. The first is to look for a common factor. So here, if we're trying to test if 4 over 5 or 4 to 5 is equal to 12 to 15, we can look at the relationship between the numerator to numerator and denominator to denominator. We're looking for that common factor. Well, 4 to 12 is multiplying by 3, and 5 to 15 is also multiplying by 3. Since the numerator and denominator were multiplied by the same value, the ratios are equivalent. 4 to 5 does equal 12 to 15. The second way is to test out cross products. So cross products is multiplying the numerator and denominator of the 2 fractions together and seeing if they are equivalent. So here we're testing if 4 to 5 is equal to 12 to 15. So we use the cross product. 4 times 5 is 60. See if that's equal to 5 times 12. Well, that's also 60. So yes, another way to show that they're equivalent. So you can use these 2 methods to test out if ratios are equivalent or not.